Imagine a void where time itself was born, 13.8 billion years ago, when the universe burst into existence in a flash of primeval light. For centuries, humanity has gazed at that night sky, yearning to know if life sparkled beyond our blue marble. We now know our cosmic tapestry spans over 50 billion light-years, a realm home to uncountable galaxies, each a potential cradle for life. Advanced observatories like WMAP and Planck map the cosmic microwave background, pinning down the universe's age with astounding precision, 13.77 plus 0.059 billion years. James Webb peers through cosmic dust, unveiling baby galaxies mere hundreds of millions of years after the Big Bang. Astronomers have even spotted monster galaxies forming just 600 million years into cosmic history, defying expectations and deepening the mystery. Cosmic inflation hints at realms beyond what we can observe, prompting whispers of parallel universes and hidden dimensions. From Hubble's breathtaking nebulae to Webb's infrared revelations, each breakthrough fuels our daring quest for life. The cosmic age problem tested our theories, but Lambda CDM emerged triumphant, framing a universe 13.8 billion years young. Tonight, we stand at the threshold of discovery, no longer mere observers, but bold seekers of answers in the silent expanse. Behold the tapestry of stars. Our Milky Way is but one of over 2 trillion galaxies, each harbouring hundreds of billions of suns. From our vantage, the universe stretches across 93 billion light-years, a scale so immense that our entire history is but a fleeting heartbeat. In 1961, astronomer Frank Drake posed a simple yet profound question: how many communicating civilizations might share our galaxy? He distilled this into the Drake equation, a probabilistic framework that multiplies factors like star formation rates and the fraction of planets that develop life. The equation's significance lies not in yielding a single number, but in guiding our searches, highlighting where uncertainties lie and where to focus our efforts. Space telescopes Kepler and TESS have now confirmed over 5,500 exoplanets, dozens in habitable zones. Among them, Hycean worlds like K2-18b, orbiting 124 light-years away, show atmospheric traces of dimethyl sulfide, an earthly biosignature. Rocky super-Earths, such as TOI 715b and the TRAPPIST-1 system's planets E, F and G, ignite our dreams of water-rich, life-friendly environments. Thus begins our journey, across light-years and time, to seek life among the stars. In the red dust of Gale Crater, NASA's Curiosity rover discovered abundant siderite, a carbonate mineral that forms only in CO2-rich, greenhouse-warmed waters, pointing to a time when Mars was warm, wet and capable of supporting microbial life. Nearby, Perseverance's exploration of Jezero Crater uncovered Chayava Falls, a rock stippled with off-white leopard spots whose chemical patterns suggest billions of years old reactions that may have nurtured ancient microbes. Further analysis at Yellowknife Bay revealed long-chain alkanes locked in 3.7 billion-year-old sediments, organic molecules vital to cell membranes, showing that Martian organics can survive for eons beneath a protective crust. Far beyond Mars, the James Webb Space Telescope peered at K2-18b and detected dimethyl sulfide and dimethyl disulfide, gases on Earth produced almost exclusively by life, with 99.7% confidence, marking the strongest biosignature hint yet in an exoplanet atmosphere. Meanwhile, methane and carbon dioxide have also been identified, deepening the intrigue, though scientists caution that volcanic or photochemical processes could mimic these gases. Detecting oxygen will be a greater challenge. Models suggest dozens of transits will be required before JWST can confirm any O2 signature, leaving methane as our most accessible trace of life. Yet chemical clues are only part of our search. We also tune into the cosmos, listening for techno-signatures. Traditional SETI focuses on narrowband radio transmissions, a Hertz-wide beacon unlike any natural source, hoping to catch an intentional signal across interstellar distances. Projects like Breakthrough Listen and the Allen Telescope Array now leverage advanced software and AI to filter out earthly interference and highlight potential alien broadcasts. New frontiers include quantum sensors and deep learning analyses that scan both radio and optical wavelengths for techno-signatures, whether laser pulses, waste heat, or megastructures, expanding our reach across the electromagnetic spectrum. In every grain of Martian dust and every photon from distant worlds, we chase the echoes and whispers of life, past, present, and beyond. In December 2021, NASA launched the James Webb Space Telescope, an infrared observatory equipped with NIR-SPEC, NIRI-SS, and MIRI instruments designed for transit spectroscopy and coronagraph. Early release science observations of WASP-39b have already revealed water vapor, carbon dioxide, and sodium in its atmosphere, heralding a new era of exoplanet characterization. Webb's powerful eyes then turned to K2-18b, detecting methane and carbon dioxide, two key biosignature candidates, with unprecedented clarity. Subsequent analyses hinted at atmospheric gases around the super-Earth, 55 Cancri e, making it the first rocky world beyond our solar system to show such signs. Astronomers now plan dozens of transits on TRAPPIST-1's temperate planets, aiming to catch the faint glow of oxygen in the years ahead. While Webb deciphers chemical whispers, SETI listens for the deliberate beacons of intelligence. The Carl G. Jansky Very Large Array has joined the hunt, scouring the microwave window for Hertz-wide signals unlike any unnatural source. The Allen Telescope Array, purpose-built for SETI, continuously monitors thousands of stars for narrowband pulses. Breakthrough. Listen, the most comprehensive search to date, leverages the Green Bank and Parkes observatories plus the automated Planet Finder to scan 1 million nearby stars. Advanced machine learning pipelines now sift through terabytes of data each night, flagging anomalous patterns that could betray an alien civilization. Beyond government missions, private enterprises are forging new paths. Rocket Lab's Venus Life Finder, in partnership with MIT, is set to deploy a photon-powered probe in 2026 to hunt for organic compounds in Venus's clouds. Yuri Milner's Breakthrough Enceladus mission aims to fly through Saturn's icy plumes, seeking microbial life with a $60 million privately funded explorer. Under NASA's Commercial Lunar Payload Services initiative, 14 companies, Astrobotic, Blue Origin, Intuitive Machines and more, are delivering science payloads to the Moon. Astrobotic's Peregrine lander will carry 24 international instruments to the lunar South Pole this year, demonstrating the power of commercial agility. In February 2024, Intuitive Machines' Odysseus lander touched down near the lunar South Pole, carrying 6 NASA instruments and marking a historic private sector milestone. From Webb's distant transits to the crackle of radio arrays and the bold ventures of private explorers, our search continues, undaunted, ever reaching into the infinite. In 1950, during a casual lunch, physicist Enrico Fermi posed the profound question, "Where is everybody?" highlighting the paradox between countless habitable worlds and our cosmic silence. The Milky Way alone hosts between 200 and 400 billion stars, and conservatively 20% of these would harbour Earth-like worlds, yielding tens of billions of potentially habitable planets. Yet, despite decades of searches, from radio telescopes scanning narrowband signals to optical SETI hunts for laser pulses, we detect nothing. One leading resolution is the Great Filter, a sequence of improbably difficult evolutionary hurdles that most civilizations never clear. This filter could lie behind us, at the emergence of complex cells or multicellular life, or loom ahead in self-destruction through nuclear war or environmental collapse. Alternatively, the zoo hypothesis posits that advanced species deliberately conceal their presence, observing us as we would wildlife in a preserve. Others propose self-limiting civilizations that retreat into virtual realities, forsaking interstellar expansion for inward exploration. Folklore of interstellar hermits and the dark forest strategy, where silence is survival, add colour to our speculations. As telescopes become more powerful and AI sifts through ever greater volumes of data, the debate intensifies, demanding open minds and relentless inquiry. Look up, and you see not just stars, but stories unwritten, the promise of worlds yet discovered. From the earliest probes to the James Webb Space Telescope's transcendent images, each mission pushes the boundaries of our knowledge, revealing the chemical fingerprints of exoplanet atmospheres and the faint glow of distant galaxies. These revelations remind us exploration is the engine of innovation. Technologies forged for space like advanced heat shields and autonomous robotics find unexpected applications on Earth, from climate monitoring to medical imaging. Yet our journey demands more than machinery. It thrives on human passion and perseverance. The Carl Sagan Institute pursues interdisciplinary astrobiology, uniting astronomers, chemists, and biologists to unravel life's cosmic origins. Looking ahead, NASA's astrophysics roadmap envisions habitable exoplanet observatory (HABEX) and large UV optical IR surveyor (LUVOIR), telescopes capable of imaging Earth-like worlds and analyzing their atmospheres for biosignatures. The Origin Space Telescope and Lynx X-ray Observatory will peer farther back in time, mapping cosmic dawn and tracking the evolution of galaxies. Private pioneers join this quest. SpaceX's Starship, slated for dozens of test flights in 2025, aims to ferry humans and cargo to Mars and beyond. Blue Origin and Rocket Lab forge new paths with reusable vehicles and dedicated astrobiology payloads. These partnerships, public and private, multiply our reach, accelerating breakthroughs once deemed impossible. As we stand on this threshold, we must ask ourselves, will we simply gaze at the stars, or will we chart our destiny among them? The universe awaits, its secrets beckon, its challenges inspire, and its horizons promise wonders beyond imagination. Before we fade to black, ask yourself, what secret does the universe still withhold from us? Is there a whisper in the void, a signal hidden just beyond our grasp? Imagine the story waiting to be told, the one you might uncover. Share your theory below in the comments and let us voyage together into the unknown. If this journey through the stars ignited your curiosity, give this video a thumbs up, subscribe for our next cosmic adventure, and hit the bell so you never miss a glimpse beyond the horizon. Your support fuels every launch, every discovery, and every question yet to be asked.